Hi students, this is Mr. Yao. Today we're going to continue to learn more about exponential story problems. In the last lesson we have learned about rate and factor. Today we're going to put the decay and the growth together and solve more problems with them. First, our knowledge. Since rate is typically given in percent and factor is typically given in decimal, let's practice converting between percent and decimal. First one, 60%. Typically when you have a percent, you can either choose to treat that as divided by 100 or you can choose to move the decimal place. Right now the decimal is right here. When you change it into a decimal, you need to move it to the left twice because that's what 100 is. So it's going to be 0.6. Same thing here. Move to the left twice, so it's 32.50. Next, move to the left twice. Since we don't have any number in the front, we need to give it a placeholder 0. So it's actually going to be 0.00109. And when you go backwards from decimal into percent, we're moving the decimal place to the right twice. So to right, so it's going to be 0.05. Don't forget the percent symbol. And right now is right here, so move to the right twice. That means you need two placeholders. So it's going to be 202100%. Move to the right twice, 23,007.8%. There you go. Now let's have a look at exponential growth and decay. You can pause here, and here's what you're going to do. You're going to put all the keywords under the right category. As in for growth, you're going to see which words means growth and which words mean decay. Hopefully you have gotten a minute to go through these. Let's have a look. Growth, here they are. Increase, triple, so 3 times. And next one is spreads, double, mark up, appreciates, percent more. Quadruple, that actually means 4 times. And then tip is on top of the money that you're paying. Next one, rise and earn, because earn means, you're earning extra money. Profit. And debt might be the one you're going to be like, wait, how come that's growth? Like you're owning money. Well, if you don't pay your debt, you're going to own more and more and more. So that's why debt is also growth. And that means the rest of them are going to be decay. So here they are. Shrink, percent less, halves, eliminates, decrease, discount, depreciate, a third, decline, and falls. So there you go. These are the ones that means decay. So we have talked about growth and decay in the previous lesson, so let's have a look at more specific formulas. They look very similar. A equals little a times 1 plus r to the t power or 1 minus r to the t power. When it's growth, of course, you're going to add on top of the 100%. Again, this 1 represents 100%. Same thing with this one, that means 100%. If it's growth, you're going to add on top of the 100%. If it's decay, you're going to subtract from the 100%. For both of them, capital A means the final amount and little a means the initial amount. So it still kind of goes together with the function we have learned. A times b to the x power. This little a, still here using little a, represents the initial amount. Capital A is replacing the f of x, so that's your final amount. R is going to be, well, next is actually t, because for both of them, t is the same. T is time. And the factor, which is typically our b, that's going to be related to r. So r in exponential growth, of course, represents a growth rate. And in exponential decay represents a decay rate. Typically, you will write it as percent, but since factor is going to be decimal, it's okay to write it as a decimal. And factor, when it's growth, is going to be add on top, so it's 1 plus r. And when it's decay, it's going to be subtracting from the 1, so it's 1 minus r. And 1 represents 100%. Now let's get into the examples. Example 1. In 1985, there were 285 cell phone subscribers in Mayville. The number of subscribers increased by 55% per year. Increased by, so this 50% represents the extra portion, so that is going to be our rate, which is 55%. A is the initial, so it's going to be 285. The question said increase, so of course that means it's going to be growth. Find the number of subscribers in 1995. You are given 1985 and is asking you to find 1995. So that means the t is going to be 10 years, since that's the difference between 1985 and 1995. As for the b, which again is the factor, since it's increase, the factor is going to be 1 plus the 55%. Change your decimal, because 55% is 0.55, so it's going to be 1.55. Equation. Let me write the formula on the top. A of t equals little a times 1 plus r to the t power, because this is increase. So there you go. 285 is the initial value. Inside parentheses is 1 plus r. Our r is 55%. So this is basically our b. So it's going to be multiplied with 1.55 to the 10th power. Put it into your calculator. That's going to give you 22812. Remember to round to the whole number, because we can't have, decimal place for subscribers. Subscribers. There you go. That's example 1. Moving on, example 2. The value of a car is 18,000 and depreciating at a rate of 12% per year. Find the value of the car after 10 years. Depreciating means it's going to be decay. A rate of 12%. So that means, since it's decaying, that means I need to subtract that from 1. So it's 1 minus 12%, which is 1 minus 0.12. So it's going to be 0.88. And it's asking for 10 years. Let's set up the equation. Little a, well, let me write on the top again. So a equals little a times 1, either plus or minus r to the t power, depending on if it's growth or decay. In this case, decay, so it's going to be subtracting. We already calculated that. 0.88. So it's 18,000 times 0.88 to the 10th power, because it's after 10 years. And put in your calculator. Since it's about money, we need to round to 2 decimal places. That's going to be 5013.02. That's example 2. Next, example 3. An investment of $5,000 earned 1.3% interest monthly. The interest was reinvested each year for 5 years. So interest is you're earning on top of the original amount, so it's going to be growth. 1.3% extra, so it's going to be 1 plus the 1.3%, which is 1 plus 0.013, which means the factor is 1.013. As for the equation, 5,000 times is 1.013. Now, about the exponent, this is where you got to be careful. The question is asking for 5 years. You can't just be like, oh, it's going to be to the 5th power, because the question said the interest is earned monthly. So you need to calculate how many months are there in 5 years. Each year has 12 months, so it's actually going to be to the 60th power. Remember to round your final answer to 2 decimal places. That's going to be 10852.67. That is example 3. Moving on, example 4. The value of your house, and it appreciates at a rate of 0.66. Be careful, it's 0.66%, so it's actually a quite small number. Find the value of the house after 20 years. Appreciates means it's going to be growth. The factor is 1 plus the 0.66%, which is 1 plus 0.0066. Be careful with that, because you need to move the decimal to the left twice. That's going to give you 1.0066. So here's your equation. Original price, which is the initial value, 495,000, times 1.0066, 20 years, and it does appreciate per year, so it's to the 20th power, which is going to give you, round to 2 decimal places, 564,603.70. Last one, example 5. Your retirement account currently has $25,473, and on average, the market holds a 3.1% interest rate quarterly. Interest means it's growth, because that's going to be on top of the original. Let's calculate the factor. 1 plus 3.1%, so it's 1 plus 0.031, which is 1.031. Find the value of the retirement account after 15 years. A equals, initial value is 25473, multiply with the factor 1.031, 2d, as for the power, 15 years, but the interest is quarterly. There are 4 quarters each year, so in 15 years, there are 60 quarters, so it's going to be to the 60th power, and that's going to give you 159,074.30. That's the last example. That's everything for this third lesson of exponential story problems. Thank you.